Okay, today we're going to be looking at the double angle formulae. So, if we start off, we've been looking at the compound angle formulae, and we can use the compound angle formulae to derive some new identities. So so if angle B is equal to angle A, we've had sine A plus B, we knew that sine of A cosine B plus cosine A sine B. Now if we have sine A plus A, we have sine A cos A plus cos A sine A, and that's sine 2A, and tidying it up we get 2 sine A cos A, and that's the double angle formula for sine. Likewise, we're going to use the same for cosine. So previously we had cosine A plus B is equal to cosine A cosine B minus sine A sine B. So if cosine is A plus A, we're going to have cosine A cosine A minus sine A sine A, which gives us the cosine 2A is going to be equal to cosine squared A minus sine squared A. Likewise for tan, we had tan A plus B was equal to tan, oops, put that into brackets, A plus tan B over 1 minus tan A tan B, and then if we have tan A plus A, we get tan A plus tan A over 1 minus tan A tan A. So tan 2A gives us 2 tan A over 1 minus tan squared A. So put together, these are what we know as the double angle formulae. Now, we already know that sine squared A plus cosine squared A equals 1. So we can use this to rewrite cosine 2A equals cosine squared A minus sine squared A. And we can get two alternative forms of this. So we can also have, by rearranging this, because we know sine squared A is going to be equal to 1 minus cosine squared A, we can have cosine 2A is equal to 2 cosine squared A minus 1, and we can also have cosine 2A equal to 1 minus 2 sine squared A. So let's just summarise the double angle formulae. So for sine, we have 2 sine A cosine A. For cosine 2A, we have cosine 2A minus sine squared A equal to 2 cosine squared A minus 1, or 1 minus 2 sine squared A. And for tan, we have 2 tan A over 1 minus tan squared A. Now these you need to memorise along with the compound angle formula as well. So let's look at some examples. So given sine x is equal to minus 3 over 5 and x is between 180 and 270, find sine 2x, cosine 2x and tan x over 2. So let's think about what this means. So if we think about our quadrant, all students trust Cambridge. We know that x is lying in this quadrant, so where tan is positive and sine x is negative here. So we would have, so for 3, this would be our value for minus 3, and this would be minus 4. Oh, this would be 5, sorry, and that would be 3. And then using Trig, not Trig, Pythagoras, sorry, you'd get minus 4 here. So you use, so when you see this, you draw your triangle and just use your simple trig identity. Sine is the opposite over the hypotenuse. Then you can use Pythagoras to get the adjacent. And then you've got this is going to be your x. So we can use this to, so basically we've got a triangle now here of minus 3, minus 4 and 5. So that's going to give us cosine x, where this is x. Cosine x is going to be minus 4 over 5, and tan x is going to be 3 over 4. So sine 2x, now we know from our double angle formula, 2 sine x cosine x, and then we just put the values for sine and cosine in. So 2 sine x is going to be minus 3 over 5 multiplied by minus 4 over 5. The negatives are going to cancel out and we're going to end up with 24 over 25. Then for cosine 2x, we've got cosine squared x minus sine squared x. So again, we take our identities, so we'd have minus 4 over 5 squared minus, and sine is minus 3 over 5 squared. Working all that out, we'll have 7, that'll be 16 minus 9 gives us 7 over 25. And finally, our what tan x over 2. So let's firstly find out what tan x. So instead of having, so we're going to use 2a equals x. So 2x equals 2 tan, now a, so a is going to be x over 2. X over 2 over 1 minus tan squared x over 2. And we know that tan x is 3 over 4. So that's going to give us 2 tan x over 2 over 1 minus tan squared x over 2. and we're going to rearrange all this. So we'll cross multiply, so we'll get 3 tan squared x over 2 plus 8 tan x over 2 minus 3 equals 0. Then we will, this here is a quadratic equation, so we will find solving this quadratic equation. We get 3 tan x over 2 minus 1 and tan x over 2 plus 3 equals 0, and that gives us tan of x over 2 equals to a third, or tan of x over 2 equals to minus 3. So remember we wanted x between 180 and 270. So if we've got, I'll write it down here. So if we have x between 180 and 270, that implies x over 2, so we're going to have to half of that. It's going to be 90 x over 2. X over 2 is going to be minus between 90 and 350. So which means this is going to be in the second quadrant. So tan is going to be negative, which is this one. So this is our answer here, because tan of x over 2 here is a positive, but because we now know this is now in this quadrant, it has to be negative, so this has to be the solution. Let's do another question. So we're going to solve 2 sine, oh no, I've written that wrong, sine 2x equals sine x for 0 less than or equal to x, for x between 0 and 360 basically. So we're going to use our double angle formula to put, so this is 2 sine x cosine x equals sine x, and we'll bring this over to this side. So it's minus sine x, and that'd be equal to 0, and now we just solve the equation. So we can take sine x out, and that's going to give us 2 cosine x minus 1. So either sine x equals 0 or sine or cosine x equals a half. So for x equals 0, x can be either 0, 180 or 360. And for cosine equals a half, x can be equal to 60. Or, if you remember, all students trust Cambridge, so this is in this quadrant, so it'll be 360 minus 60, which is 300. So therefore, x can be 0, 180, 6, I should write that in order of size actually. Doesn't matter, but it makes it look neater. 0 degrees, 60 degrees, 180 degrees, 300 degrees, or 360 degrees. Now, let's do one that has cosine 2x. So we're going to solve cosine 2x plus 3 sine x equals 2 for x between 0 and 2 pi. Now, we're going to choose, so when you have cosine 2x, you need to look at the rest of the equation and think which identity for cosine 2x is going to be the most useful. And therefore, in this case, we're going to use cosine 2x equals 1 minus 2 sine squared x, because we've got a sine here. So we'll get them all in the same trig identity. So let's go 1 minus 2 sine squared x plus 3 sine x equals 2, and we're going to rearrange this. So we have 2 sine squared x minus 3 sine x plus 1 equals 0. And so you can see now we've got a nice quadratic equation. So we have 2 sine x sine x, and this will be minus 1 equals to 0, and so sine x will be equal to a half, or sine x will be equal to 1, and so x is a half when pi over 6, and x is 1 at pi over 2. It's also equal to a half if you think about the quadrant. So this is positive, so it's in here. So it'll be pi minus, on this one, what was our, for this one, this one's be pi minus pi over 6, which is equal to 5 pi over 6. Oops. So our values of x are, where did I write it? Pi over 6, pi over 2, and 5 pi over 6. Now we're going to do a couple of examples which are a bit more tricky. So we're going to prove that tan 3x is equivalent to 3 tan x minus tan cubed x over 1 minus 3 tan squared x. So we're going to look at the left hand side. So left hand side, tan, and we're going to write this as 2x plus x. So we can now use the compound angle formula for tan. And let's just write that out again so that we have it. So that would be tan a plus b is equal to tan a plus tan b over 1 minus tan a plus b. So let's write that in. So we'll have tan, instead of a, it's going to be 2x plus tan x over 1 minus tan 2x tan x. Now we're going to substitute tan 2x for its double angle equivalent, which is over 1 minus tan squared x. This is going to get a bit messy. So this is 2 tan x over 1 minus tan squared x, and we're going to put that into a big bracket just to keep it some bit tidy, over 1 minus tan x, so this is tan x, then we've got our 2 tan x over 1 minus tan squared x, and now we've got some expanding of brackets and some tidying, so we're going to get 2 tan x plus tan x 1 minus tan squared x over 1 minus tan squared x minus 2 tan squared x, and that then gets simplified down to 3 tan x minus tan cubed x over 1 minus 3 tan squared x, which is equivalent to the right hand side. Let's do another one. So to prove that 2 sine x minus y over cos x minus y minus cos x plus y is equivalent to cot y minus cot x. So again, we're going to use the compound angle formulae for sines and cosines. So the left hand side is going to be equivalent, for the top bit is going to be 2 sine x cosine y minus 2 cos x sine y over cos x cos y plus sine x sine y minus cos x cos y minus sine x sine y. So we've just literally taken the compound angle formulae for this and put them in. Now we've got to do some simplifying of the denominator. So we'll leave the numerator alone just now. And we can see that cos x, cos y, they're going to cancel each other out. And there's sin x, sin y, sin x, sin y, minus and a minus make a positive. So we're going to end up with 2 sin x, sin y. And now we're going to separate out these two. So we'll have 2 sin x cosine y over 2 sin x sin y minus 2 cos x sin y over 2 sin x sin y. And we can cancel this and this, and this and this, and the 2's as well. So it's going to give us cos y sin y minus cos x sine x, which gives us cot y minus cot x, which is equivalent to the right hand side. So I hope that helps.